Good morning, everybody. So, today we're gonna mix things up a little bit. Today we're going to have asynchronous class where you could just watch a little video now. Now, first things first, if anybody has any questions at the end of the video, please leave it in the comment section. Feel free to leave a like, it will help the channel grow. And let's get into class this morning. So, today we'll be doing a little bit of fractions. Now, we all know this whole stigma against fractions. Nobody likes fractions. Everybody likes whole numbers to work with. Well, you can see what you could do now. So here is the scene. We can add fractions, we can subtract fractions, we can multiply, and we can divide. Now, if I show you how to add or subtract, I just had to show you one operation there. Because addition is the same thing like subtraction. So once I show you to add, all you will know how to subtract fractions. So let me start something. Now, everybody know the procedure. When you add in fractions, the first thing we just look for is this thing called the LCM. So for example, 1, 2 over 3 plus 5 over 7. Well, my LCM will be 21. And this is how we just see it. And I'm sure everybody will agree with me here. 3 into 21 is 7. 7 by 2 is 14. Plus 7 into 21 is 3. 3 by 5 is 15. We add 14 plus 15 and we get 29 over 21. Easy peasy lemon squeezy. Let's try the second one. I'm sure everybody will agree with me. LCM here is 6. Well, 2 into 6 is 3. 3 by 1 is 3. Plus 3 into 6 is 2. 2 by 1 is 2. 3 plus 2 is 5. So we get 5 over 6. Now we'll try the next one here. So pause the video, take a couple minutes if you have to, or a couple seconds if you have to, and try and figure out what the LCM is in this case. 3 over 5 plus 3 over 4. The LCM is 20. And we talk it out. 5 into 20 is 4. 4 threes are 12. Plus 4 into 20 is 5. 5 threes are 15. 12 and 15, that is 1 and 1 is 2. 5, 6, 7. We get 27 over 20. So far, so good. What about the fourth example? 6 over 14 plus 2 over 3. What's the LCM there? Now, it will be difficult to try and figure out what the LCM is. Some people will have to go in their calculators and see what's the lowest common multiple of 14 and 3, what they have in common. But if we look at examples 1, example 2, and example 3, take a couple seconds. How did we get 21? How did we get 6? How did we get 20? We get 21 by multiplying the two denominators in the question. We get 6 by multiplying the two denominators in the question. And we get 20 by multiplying the two denominators in the question. It just so happened that, for example, 1, 2, and 3, that denominator we get by multiplication is the LCM. But, it really don't matter. It really don't matter. If, for example, 2, I decided to say, well, here was the scene. The LCM is 12. I would have still gotten 5 over 6 as my answer. And I'll illustrate it for you here. If I say 1 over 2 plus 1 over 3, and I say by some miraculous mistake, the LCM I got was 12. 2 into 12 is 6. 6 by 1 is 6. Plus 3 into 12 is 4. 4 by 1 is 4. 6 plus 4 is 10 over 12. This can be reduced to 5 over 6. But this fella here, he was not an LCM. He was just a common multiple. So this will change how we'll look at fractions a little bit. Just because I have this whole thing called LCM, that does not mean that I have to find the LCM when adding or subtracting fractions. As long as I get some common multiple, brother man, I could go ahead and add or subtract my fractions. It just so happens that in the end, if it can be reduced, I'll go reduce it. I mean, that's a small thing. So let's try something here. So, pull out all the calculators. 14 by 3. Let's try and work out what 14 by 3 is. We had 42. No problem. Now, I don't know if this is my LCM or if it's just a common denominator. So, 14 into 42 is 3. 6 by 3 is 18. Plus 3 into 42 is 14. 14 by 2 is 28. 18 plus 28 is 46. So I get 46 over 42. But this can be reduced. 46 over 42, it could be reduced to 23 over 21. So this means to say that 42 was not my LCM. 21 would have been my LCM. And the reason we will get 21 there, you go look back at the question and be about 14 cannot go into 21. But 6 over 14 can be reduced. Alright? So when we try to figure out what this common denominator is, or common multiple, just multiply the denominators by each other. Let me look at the next example now. The next example says 2 over 97 plus 6 over 35. Again, it's difficult to figure out what the LCM is. For the sixth example, same. It's difficult to figure out what the LCM is. So we'll go with the whole common denominator business. Alright? So these two examples here are the same. These two examples are the same. So 3 over 8 plus 1 over 4. I mean, we know that our LCM is 8. But I want to work it out using a common denominator. Alright? If I want to figure out what the common denominator is, I need to multiply the two denominators by each other. 8 by 4 is 32. And by all means, if you want to work it out using a LCM, no problem. No problem at all. But this method will help in every single type of addition or subtraction of fractions, whether it be regular fractions or algebraic fractions. 8 into 42 is 4. 4 by 3 is 12. 4 into 32 is 8. 8 by 1 is 8. Well, 8 plus 12 is 20 over 32. Now this can be reduced. 20 over 32. It can be reduced to 5 over 8. So 32 was my common denominator. But because it could be reduced, 8 would be my LCM. Let's try the next example. 97 multiplied by 35, 3395. 97 into this big number here is 35. And well, 35 multiplied by 2 is 70. Plus 35 into this big number here is 97. And 97 by 6 is 582. And you all can work this out with me in your calculators as well. We add it to 70, we get 652 over 3395. And now you'll be wondering, well, sir, how am I going to reduce this? Don't worry. In future classes, I will show you all tricks with your calculators where you can reduce this using a calculator. And all you have to do is enter 652 over 3395 and it automatically reduces it for you. 3395. So this cannot be reduced. So that means that 3395 was my LCM. Right, let's try the next example. So in this one, it could be a little more difficult because now I have three fractions here. Well, 7 by 9 by 4 is 252. Well, 252 divided by 7 is 36, and I'm multiplying it by the 2. I get 72. Plus 252 divided by 9, 28, multiplied by 4, 112. Minus 252 divided by 4, 63. 63 by 1 is 63. So when I work out this number here, I get 72 plus 112 minus 63 is equal to 121 over 252. So 121 over 252 252 is the LCM because this cannot be broken up further. Now I want to introduce a concept to you guys that will make life real easy. And the concept is highlighted on the top left here. We have this concept called a big denominator over a small denominator multiplied by a numerator. And I want to introduce that concept down here. Now, when I say big denominator, well, what does that mean? The big denominator is this common denominator or the common multiple when we multiply everything by each other. But instead of multiplying everything by each other like what we have been doing before and writing down what that number is, I'm not going to multiply it out and get one single number. I'm going to put my big denominator as a product of each of the denominators. 3 multiplied by 4 multiplied by 6 multiplied by 7. Alright, if I were to multiply it out, I will get some common denominator, but I'm expressing it like this for a particular reason. The calculations I want you all to start doing for each fraction will be a different calculation. And each fraction works on this formula I have on top. Big denominator multiplied by numerator, big denominator over small denominator multiplied by the numerator. So let's try it for my first fraction, then I'll do it for my second fraction, then my third fraction, and then my fourth fraction, and see what I get. So for my first fraction, which is 7 over 3, I just put in it here. My big denominator is 3 multiplied by 4 multiplied by 6 multiplied by 7. My small denominator will be the denominator on the fraction. Which kind of makes sense. One big, one small. And I must multiply by my numerator, which is 7. And let's see what number I get. Well, the 3 will always cancel with the 3 in this case. And the remainder I have here is 4 by 6 by 7 by 7. So I get 1176. So my first number in my answer will be 1176 plus. I'm going on to my next fraction. My next fraction is 11 over 4. Now in this case, my small denominator will be 4 and my numerator going to be 11. But my big denominator is still my big denominator, which is 3, 4, 6, 7 over 4 multiplied by 11. Big denominator over small denominator multiplied by numerator. The 4 will cancel with the 4 in this case, and I will get 3 by 6 by 7 by 11. And I get 1386. 1386. So my second number in my answer will be 1386. Take away. My third fraction is 5 over 7. In this case, my small denominator will be 7. My big denominator I change. My numerator will be 5. So big denominator 3, 4, 6, 7 divided by small denominator multiplied by numerator. The 7 cancels with the 7 and I go get, 5 over 6. So this will be 6. Nice. The 6 cancels with the 6 and I get 3 by 4 by 7 by 5. I get 420. So it's minus 420 plus my last fraction. And see if you could pause the video and figure out what will be the number on the last fraction. The last fraction is 3 over 7. So it's going to be 3, 4, 6, 7 all over 7 multiplied by 3. 7 cancels with the 7. I get 3 by 4 by 6 by 3. 216. So plus 216 is equal to, I'm going to work out what the numerator is in my answer. So 1176 plus 1386 take away 420 plus 216 equals, I get 2358. And remember, I'm expressing this as an answer now. So I don't want to put 3 by 4 by 6 by 7. I'll just look at what it is. 3 by 4 by 6 by 7 is 504. And that's it. As simple as that. That's it. So if I perform the same procedure for any one of the questions above, I'll get the same answer. And I want you all to honestly try it. Pause the video, go back in all of the previous examples and try and work out the questions using big denominator over small denominator multiplied by numerator, and see if you don't get the same answers as we got before. Now, this procedure, it works exceptionally well because everybody in the first class told me that algebra was the problem. Well, guess what? Algebra comes up in fractions as well. So if I have this fella here and I have to simplify, well, we have two questions here, right? We have to simplify these two questions. Brother man, pressure. Was pressure. Now it's easy. I'm going to do the working using big denominator over small denominator multiplied by numerator. And in the last one here, this one here, we're going to learn how to do it a little quicker. So pause the video and try this first one for yourself. So the solution is going to start now. I'll have 3 by y by 13. Brother man, that fella is my big denominator. Well, let me tackle my first fraction, which is x over 3. Put it on top here, x over 3. Now remember, the procedure is big denominator 3 by y by 13 over small denominator multiplied by numerator. Pull this a little further in the corner there. Well, 3 cancels with the 3. Y by 13 is 13y. 13y by x is just 13xy. So I get 13xy for my first answer. Plus, alright, my next fraction is 4 over y. Well, big denominator 3y 13 over small denominator multiplied by numerator. The y cancels with the y. I get 3 by 13 by 4. 3 by 13 by 4 is 156. Alright, So I get plus 156 here. Take away the last one. Again, let me move this fella around a little bit. Right, the last fella is going to be 3, well, 11 over 13. I'm going to have 3 by y by 13 over 13 multiplied by 11. Bam shot, bam shot. 3 by y is 3y, and 3y multiplied by 11 is 33y minus 33y. Now, I'll give you all a piece of advice here, and we will be doing this in the future. Whenever adding different things, I can only add things that visually look the same. For example, I can only add numbers to numbers. So let's divert our attention up in the corner here. I'll put it in a little box, and there's just a little side note, okay? I can add numbers to numbers. 12 plus 2 plus 6. I can add those numbers. I get 12 and 2 is 14 and 6 is 20. No problem at all. But when I start introducing letters into a sum or a difference, I can only add things that look the same. So if I have a x plus 2 plus 3x plus y, I can only add variables that look the same. So I can add this x to the 3x and I get 4x. I cannot add 2 to anything else because I do not have no numbers standing by themselves. So here remains as plus 2. And again, I don't have no other y's to add to the y. But suppose I have x squared plus x plus 3x. Well, x squared, brother man, he different from x. Visually, they're not looking the same. So I can't add x squared to x. Actually, I have nothing to add to x squared there. So here remains as x squared plus I have an x to add to the 3x, and I get a 4x here. So the only time I can add things is if they look exactly the same in terms of variables. Variables are any letters. So in this question down here now, 13xy, I don't have no other xy's to add to it. 156, I have no other numbers to add to it. 33y, I have no other y's to add to it. So I have nothing to add to each other there. So here remains as 13xy plus 156 take away 33y all over, and like I said before, we work out what the denominator is. 13 by 3 is 39y. And please, 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 do not cancel this y with this y and this y here. Don't do that. Okay? For now, whenever we're working out LCMs and either the numerator or the denominator has more than one term on it, do not cancel. You see how for this example here, I was able to cancel the 20 over 32 because I had one term on top and I had one term below. And write this down and I'll note when I'll taking it down. I have one term on top and one term below. So I am well within my right to cancel. But when I come down here, I have more than one term on top. So as soon as I have more than one term, refrain from cancelling, please. So let me do the fella we have in the corner down here now. 2 over x plus 4 over y take away 1 over 2. So pause the video, try it for yourself, and let's see if you get the same answer I got. Well, my big denominator is going to be x by y by 2. And this is where we're going to learn a little shortcut if you want to use the shortcut. If you want to go ahead and write it down like how we have been writing it for this case, then this case, then this case, and work out what each answer will be, by all means, feel free to do so. If you want to use the shortcut, feel free to do so as well, but be confident with your shortcut. So my first fraction is 2 over x. I want to know how it is I'm going and work out what the number down here going to be without writing out the cancellation and then the multiplication. Now observe something with the previous example. For my first fraction, the 3 cancelled from my denominator. Okay. For my second fraction, the y cancelled from my denominator. Alright. For my third fraction, the 13 cancelled from my denominator. So whichever fraction I'm working with, that small denominator is cancelled from my big denominator every time. Okay, so if I'm going back and dealing with my first fraction, if the 3 is cancelled, the only things I multiply is y by 13 by x. And I want a little understand the pattern here. For the second fraction, the y cancels, so it's 3 by 13 by 4. For the third fraction, the 13 cancels, so it's 3 by y by 11. Well, let me try that down here now. Let me try it down here and see what we get. For my first fraction, well, the x is going to be cancelled. So the multiplication is going to be y by 2 by 2. Y by 2 is 2y. 2y by 2 is 4y. So I get 4y up here. Plus, what will cancel here in the second fraction? Y. Well, if the y cancels, the multiplication is going to be x by 2 by 4. X by 2 is 2x. 2x by 4 is 8x. Take away. Now the 2 will cancel with the 2. And the multiplication is going to be x by y by 1. Which is x. Y. And now to express it as a complete fraction, it'll be 4y plus 8x minus xy over, and now I multiply out my big denominator, 2xy. And we usually put the numbers in front of any variables. Now, I have to ask the question, and I want you all to pause the video if you want to attempt to answer it for yourself. I mean, challenge yourself now. Come on, we're here to learn. What does LCM do? Or what does adding a number of fractions, what are we actually doing there? So if I go back up, and I'm going to answer the question now. So if you want to pause it now. I took 2 fractions and I expressed it as 1 fraction. I take 2 fractions and I express it as 1. I take 2 fractions, I express it as 1. Then I take 3 fractions and I express it as 1. Then I take 4 fractions and I express it as 1. I take 3 fractions and I express it as 1. So this whole LCM procedure, or the whole simplifying procedure, it is a method where we take the sums or differences of any number of fractions, any number, and express them as a single fraction. So take these 2 to try on your own. Express as a single fraction the first one and the second one. So pause the video and I'm going to do the solutions now. Well, my big denominator is going to be 3 by 5x by 2y. Well, we all know that how the 3 will cancel with the 3. and the multiplication is going to be 5x by 2y, which is 10xy, multiplied by 2, which is 20xy, plus the 5x will cancel with the 5x, so I'll have 3 by 2y is 6y, and 6y by 4 is 24y. Take away, the 2y will cancel with the 2y. I get 5x by 3, that is 15x, and 15x by 3 is 45x. Now note, I have a xy, I have a y, and I have a x. I have no like terms, so nothing visually looks the same, so I cannot add them together. So my answer is going to be 20xy plus 24y minus 45x over 3 by 5x is 15x, and 15x by 2y is 30xy. And we just now simplified an algebraic fraction. Now I hope all you're enjoying going on, because we now scratching the surface for algebra. And this method helps you a lot. It goes a long way. This method goes all the way up to form 6, and it helps you big time. Last one. Well, 7 by 4 by 14. I know the first thing we're going to cancel out will be my 7. So my multiplication is going to be 4 by 14 by 6, which is 336. Plus my second cancellation, the 4 is going to cancel with the 4. So I'll have 7 by 14 by 3, which is 294. Take away, the 14 is going to cancel with the 14, so I get 7 by 4 by 5, 140. Now, these are 3 numbers. I can subtract numbers from numbers. 336 plus 294 take away 140 is equal to 490 over, and now I'll multiply with my denominator. 7 by 4 by 14 is 392. Now this could be reduced. 490 over 392. 490 over 392 is equal to 5 over 4. So in this case here, 392 was not my LCM. I just want to check over this last one here, right? 6 over 7 plus 3 over 4, take away 5 over 14. Yeah, so 5 over 4 is my answer. So that means that my LCM in this case here was not 392, it would have been 4. Alright? Cool. Now, if anybody has any questions, like I said, leave a comment in the comment section down below. Please everyone, go and accept the invite on the Google Classroom for those of you all who are in this remedial class. And next week, sneak peek, multiplying and dividing fractions. Also, I would like for you all to tell me if you all like this kind of videos, or would you all prefer the live interaction, because by all means this is a little bit easier for me and I can respond accordingly if I see you guys put things in the comments, whereas I teaching live and I have to wait for my voice to reach all your comments to reach back to me, and then my voice to reach back to all you. That is why last week class takes so long, alright, because we had that interaction. But if you all like these types of videos, let me know. If not, let me know. Leave a like, leave a comment, and I'll see you guys next week.